Namaste, my dear students. Once again, I am here in the DSRT studios, that is in Chandana Vahini, and this is Samveda e-learning for you people. And we were discussing with coordinate geometry, introduction, and all. I am Sridhar, you know. Now, let's continue with coordinate geometry. So, I quickly tell you what all the things you studied in the last class. Before that, did you attend the assignment? I had given you 4 points as rectangle, square and parallelogram. And one question, do these 3 points they form a triangle? So, I hope you have done and you will have done that. With the hope that you have done that, I am starting this class. Now, this is a very well known topic to you, but dealt in a different way. The topic of today's class is your geometrical friend from your childhood, a triangle. What is a triangle? Now, that's a big question. A small answer, but that's a big question that can be defined in so many possible ways. What is a triangle? See, for you, it's a three-sided closed figure, that's all. That is very simple, that's enough. A triangle. And basically, you know its area. How the area of a triangle is calculated? It is half into base into height. Half the product of base and height. If it is a right angle triangle, it is half the product of the sides containing the right angle, half BH. If it is area of an equilateral triangle, it is root 3 a square by 4 square units. These are all the geometrical formula you have derived, you have used, you have done so many problems on this, but how to find the area of a triangle when its vertices are given to you? How to find the area of a triangle when its vertices are known to us? Welcome to area of a triangle analytical. This is class 10 syllabus. You have the triangle A, B, C. A is x1, y1, B is x2, y2 and C is x3, y3. How to find the area with x1, x2, x3, y1, y2, y3 is our main concern of this class. Also, how to use this formula in various mathematical situations. How to use or apply this formula, how to use this technique is the concern. The formula I will give you directly, the derivation part, as again I am telling you, please discuss with your classroom teacher. Formula for area of a triangle analytical. I will be a little slow in explaining this formula because this formula is not so easily understandable. It needs some explanation. Derivation part, I am not going for that. Read this. Area of a triangle is half. You know some notation there? You have studied this in your AP. Sum of first n natural numbers, sigma n. Yeah, sigma. What sigma means? Summation. What summation means? Add up. Total it up. That's all. Half sigma. You write x. Don't write 1, 2, 3 there. Huh? You write x. In the brackets, you write y minus y. See how to remember this? I am telling you very easily. Half sigma x inside the bracket y minus y. Now from x, observe it, write 1, 2, 3. 1, 2, do you remember? Half x y minus y for x1, for the remaining 2 y's 2 and 3. 1, 2, 3. This is the formula. Half sigma x1 into y2 minus y3. So this is concised form. Now this is the expanded form. How to get the expanded form? You got x1, you got x2, you got x3, you got y1, y2, y3. Change them in the cyclic order. See here, x1 should be substituted by x2, x2 should be substituted by x3, and x3 should be substituted by x1. Cyclic order. Similarly, y1. You change in the original formula, you will get the expanded formula. Now, these figures will help you. Do you know in which direction we are changing? I said clockwise, right? You can change it in anti-clockwise also. What happens? I will let you know in the problems. Change them in the cyclic order. Clockwise you change. x1 to x2, y1 to y2, x2 to y3, y2 to y3, y3 to y1, and x3 to x1. Now let us change. See what happens. This is the area of triangle. I told you x, y minus y, 1, 2, 3. Now that will be the first term. What is x1 into y2 minus y3 is the first term. Half. Open the bracket. First term x1 y2 minus y3 plus y plus summation. Add. Find the total. Now change the variables in the cyclic order. What are the variables? x1, x2, x3, y1, y2, y3. x1 becomes x2. See there? x2 in the next term becomes x3. Only 3 terms. y2, y3, y3, y1. Third term only. y3, y1, y1, y2. Don't remember this mechanically. x1, y2 minus y3. No, don't do that. First term sigma, x, y minus y, 1, 2, 3. Change them cyclic order. You get 3 terms. That's all. Even you don't have to remember this. Write it on the spot. Wherever you use this formula, you use this formula on the spot. Write it on your own. Please don't try to by heart this. No, that will not help you. This is the big formula. I have to remember this. This can be derived. The derivation is very fascinating. It is very exciting. So I am not doing the derivation part in this class. I am sorry for that. Please take the assistance of your teachers. Now, these are 3 different points. When origin is one such point of one such vertex of the given triangle, then what will be the formula? Origin is one of the vertices, x1, y1 is the second vertex, x2, y2, change it there, okay? It is repeated x1, y1, make it x2, y2 as the other vertices. Then the area of triangle is half x1, y2 minus x2, y1. Change x1 to x2, x2 to x1. This is absolute change. x1, y2 minus x2, y1. This formula is used only when origin is one of the vertices. Let us pass on. Few things about the area of triangle. If the area of the triangle on calculations becomes 0, then those points will be collinear, or else this is the condition for any 3 points to be collinear. The area formed by those triangles, those points shall be 0. You know, in the last class we did how the points were collinear in the distance formula class. Find 3 distances, sum of any 2 will be other. Now take the 3 points, write the formula for area of triangle, substitute, finally you will get 0. Finally, if you will get 0, then the given points are collinear. They lie on the same straight line. Area of a triangle is denoted by the symbol D, that is delta. I told you the condition for any 3 points to be collinear is delta equal to 0, area must be 0. If you find the area of a polygon, then divide it into number of possible triangles and sum up their areas. See, for example, a quadrilateral is given to you and you are asked to find the area of this quadrilateral. Draw one diagonal, you will get two triangles. Find the area of two triangles and then add up, you will get the area of the quadrilateral. Likewise, if you have a pentagon, so in a pentagon, three triangles can be there. There is formula, there is a result. How many triangles can be drawn in a polygon of n sides? So n minus 2 number of triangles can be obtained. See, if the vertices are taken clockwise, I told you x1, x2, x3, y1, y2, y3. On calculations, you will find the value, the obtained area value is positive. If reversed, if you take the points anti-clockwise, there will be no change in the magnitude, there will be no change in the value, only change you can see is negative. Anyway, area can never be taken negative. In that case, we will neglect the negative sign and we will fix onto the obtained value, that is positive value. Area is always positive, right? If you take that, you will get negative, that's all. So why can't we take that? If for experiments you can take negative, area cannot be negative. Find the area of the triangles. 3 points are given to you. 3, 8, minus 4, 2, 5, minus 1. Write the data like this, or x1 equal to, x2 equal to, x3 equal to, y1 equal to, y2 equal to, y2 equal to. That is left to you. You write in your desired way, but write it correctly, right? Next, formula. I told you, write it, don't remember that. x1 to x2, x2 to x3, y1, y2 to y3, y3 to y1, y3 to y1, are you observing? y3 to y1 and y1 to y2. Substitute. What is x1? 3. What is y2? 2. What is y3? Minus 1. Minus of minus is plus, 2 plus 1. Similarly, minus 4 into minus 1 minus 8. 5 into 8 minus 2. 3 into 3 is 9. Minus 9 into minus 4 is 36. 5 into 6 is 30. Totally 75 by 2 square units. That is the area of the triangle you have found. Did you understand this? Yes, sir. Next question. Same type of question. Find the area of the triangle whose angular points are given. Same vertex, angular point, one and the same. Angular points are given to you. Data. What is given? Data is written. Fine. Formula is written and substituted. The value obtained is 58 by 2, 29 square units. Simplification, substitution is yours and it is original, right? Don't ever mistake, don't do mistake, don't commit mistakes in substitution. 29 by 58 by 2, that is 29 square units. We will pass on. The problem of the discussion has come. Collinear. The condition I told you just 5 minutes before. Now the problem. See, show that the points 1 comma minus 1, 2 comma 1, 4 comma 5 are collinear. Write the data. x1 y1 equal to, x2 y2 equal to, and x3 y3 equal to 1 comma minus 1, 2 comma 1 and 4 comma 5. For these given points to be collinear, the condition is that triangular area formed by these points must be 0. Given. Sir, do you mean to say we have to write this sentence? Not at all required. right? You write delta equal to 0, that is understandable, that is more than enough. See, this is classroom, you know. See, inside the class, inside the study room, everything should be dealt in detail. Okay, there shall not be scope for any type of confusion. Data, principle, or the condition, formula. I repeat, don't try to remember the formula, please write the formula whenever you write. Substitute. Oh, I have given twice. No problem. Substitute. Clear? See, what is the final answer? 0. Area of the triangle found by the given points is observed 0. It is found 0. Therefore, the points must be collinear. Clear? I mean to say, you remember in my last class I had given you an assignment, show that these points do not form a triangle. Take those points, apply this formula, you will get 0 as the result. They cannot form a triangle. They are collinear. They lie on the same straight line. Clear? Right. Next question. Same thing. Show that these points are collinear. Right? Write the data. Write the condition. Write the formula. Substitute. See the final answer. 0. What can you conclude? The area of the triangle is found 0. Therefore, the points must be invariably collinear. They must lie on the same straight line. Okay. Clear? Next question. See here how the questions are framed. See, the problem says the points are collinear and x component of the first vertex is not known. See, the triangle is found by x comma minus 1, 5 comma 7, 4 comma 5. When do they become collinear, or what is the value of x? So, for what value of x these points become collinear? For what value of x these points give area of the triangle 0? That is the concern. Again, what you use? The same principle. What is the principle? The principle for the points to be collinear is delta equal to 0. Write the data. Formula is there. Now, in the beginning itself I have taken 0. Why? Because problem says the points are collinear. That's why 0. Substitute. Shift 2 to the right hand side. 2 into 0 will be 0. X into minus 4 plus 5 into 12 plus 8 into minus 8 equal to 0. Minus 4x plus 60 minus 64 equal to 0. Minus 4x minus 4 equal to 0, then minus 4x equal to 4, easy, then x equal to minus 1. The point, oh sorry, they have given you x equal to, they have asked you to find the value. In case if they ask you to write the point also, substitute the value of x in A. I have got a quadrilateral, right? What is A? 1 comma 2. What is B? 6 comma 3. What is C? 5 comma 3. What is D? 3 comma 4. We want the area of this quadrilateral A, B, C, D. Now, by geometry, what is the formula used? Area of a quadrilateral, do you remember from your 8th standard? Area of a quadrilateral is, yes, come on, write it. I will give you a few seconds, write it. Geometrical formula. Area of a quadrilateral equal to half into the diagonal into sum of the heights drawn onto the diagonal, half d into h1 plus h2. Leave it. Now you have to find the area of this quadrilateral analytically. You have to use the formula of area of a triangle and then do. For that, to use the area of triangle, I need triangle. To get a triangle inside the quadrilateral, I need a diagonal. I need one of the diagonals to be written. dB I have taken. Sir, why did you leave AC? You draw all AC also. You are dividing the area, you are not extending, you are not reducing the area by drawing AC. Clear? By drawing the diagonal AC, you are not expanding or you are not reducing the area. AC has no influence. dB I have written, and that divides the quadrilateral into two triangles. Triangle 1, which is that ADB, second triangle, BDC, or ABD clockwise, BCD, another triangle. Now write the data. If you add area of triangle 1 and if you add area of triangle 2, you will get the area of the quadrilateral. Right? That's what I have given you. Area of ABCD is equal to area of ABD plus area of BDC. For area of ABD, write down x1, y1, ABD, x2, y2, x3, y3. Write the formula, substitute the values of B, A and D, you will get 8 by 2. Finally, I am not going to tell you about substitution. You make sure every single value known is substituted properly and it is written properly, simplified correctly, and that gives you 8 by 2. 8 by 2 is 4 square units, that is the area of triangle. Next triangle. For triangle BDC, write the formula, substitute, you will get half square units. See there? One triangle is obtained 4 and the other triangle, you can see it is half square units. Now, area of the quadrilateral ABCD is equal to area ABD plus area BDC, that is 4 plus 1 by 2. One is a number and other is a fraction. Most of the people you write it as 5 by 2. Please don't do that. Take the LCM. 4 plus half, common sense, 4 and half. 9 by 2 is 4 and half. Correct? See, take the LCM and add. A number and fraction, whenever you want to add a number and a fraction, you need the help of LCM. I have seen as a teacher, most of the students, they write this as 5 by 2. The problem is, they don't see that properly. Observation and the skill of observation, what we call as observational skills, most important in science subjects, whether it is maths or physics or chemistry, whatever it is. Observe what is there and then proceed. That is, area of the quadrilateral is ABCD. Now, based on this topic, I have given you some assignment. That is all about area of triangle you have in your textbook. Find the area of the triangle found by the point 6, 3, minus 3, 5 and 4, minus 2. A, C plus A, C and minus A, C minus A. So the second question, you don't have any value, you have only A, C and all, and you will get a standard result. You see what is that. After doing your assignment, please check it with your concerned teacher. Find the area of the quadrilateral whose angular points are, just now we did the problem on quadrilateral. Like that, I have given you two sets of points. You will find the area of the quadrilateral. So in the next, that is question number 3, question number 3, you need to show these two sets of points. These two sets of points are collinear. 2, 5, 4, 6, 8, 8, 1, minus 1, 2, 1 and 4, 5. So in these two cases, you will get delta 0. that is area of triangle 0. Next one, this is very important. When you come to your PU classes, you will understand this importance. That is, this is a standard result. If the points a comma 0, 0 comma b and x comma y are collinear, then show that x by a plus y by b equal to 1. You don't worry about any other thing, you don't worry about the standard of the question, take the data, write the formula. I am telling you, write the formula, substitute, simplify, you will get the result. Okay? This is all about area of a triangle. This is all about the coordinate geometry, and this is all about today's class. And remember, this unit, that is coordinate geometry, is very, very interesting and very, very important for all other branches, all other kinds of mathematics. If you go higher and higher in this branch, you will really understand the importance of coordinate geometry. See, imagine, so this geometry is of very, 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 very helpful to the mankind, and hats off to those scientists and mathematicians who found and developed this branch of mathematics. So it's a great opportunity for me to stand before you and deliver few classes. I remember 3 to 4 classes on coordinate geometry in this particular stage, and I hope I've made myself very clear about the theory part and about the formula. Children, that's all about coordinate geometry, and all the best for your coming examinations and your coming career. From my side, best of luck. Namaste. I am Sridhar from assistant teacher, Government Composite PU College, and I am working in high school section in Urkere, Tumkur Taluk. All the best, children. Happy day. Okay? Thank you very much.